Okay. And on this one. Okay. Can you hear me? I want to make sure the audio is working. Can you
Yes.
hear me?
Yes.
Oh, good. Very good. Let me close some of these things here so I have enough room. All right. Now let me share what we'll be doing in a few minutes. Can you see the screen?
Yes.
Test of hypothesis, regression, and correlation. Now we'll start with statistical hypothesis testing. I'll give you the introduction, maybe on Tuesday, since it's Monday. It's a public holiday, right?
Correct.
All right, let's see. Since you can see there, everything. Say a statistical hypothesis is a claim or conjecture about a population parameter. Remember, when you say population parameter, we are talking about mean, standard deviation, proportion, and so on. Population parameter is basically a numerical estimate of a population characteristics. Now, so the claim may be true, may be false, but we won't know until we test it. So that's why I call it a hypothesis. In testing hypothesis, we do the following: we define the parameter, okay, the population parameter. Then we state the hypothesis that will need to be investigated, and we give the significance level. I've already explained it when we are doing confidence interval. If you're 95% confident, your chance of being wrong is 5%, meaning that your alpha is 0.05. If you are 90% confidence, your chance of being wrong is 10%, meaning that your alpha will be 0.10. So we give our significant level, then we select a sample from the population, we collect data from that sample, we perform all the necessary calculations that we need for the test, then do the test and reach a conclusion. So we use this almost every day. Those in the science, business, education, health, or like this COVID-19 vaccine. It was tested with they did what they call clinical trials to test the efficacy of the vaccine before it can then be approved by the FDA and other health authorities. Now, so that's what we do under hypothesis testing. Collect the sample, we analyze, make a conclusion. Now, some of the questions that are addressed through hypothesis testing, many of them, this is just a few examples of it. 1 minute. Does a particular medication lower patient blood pressure? We don't know until we collect sample and then conduct a clinical trial. Does seatbelt reduce the severity of injuries caused by accidents? Well, all those claims they have been tested. Then does the public or customer prefer a certain color in a new line of fashion? Does advertisement increase sales? Stuff like that. That's what the test hypothesis. Now, let's look at the types of hypothesis we normally test. For the type of hypothesis, we have two major types of hypothesis. Any question? Somebody was saying something. Any question so far? Okay, good. There are two types. We have the null hypothesis. The symbol is HO. Now, it's a statement that the value of the population parameter assumed is equal to some claimed value. Now, the symbol we use to state null hypothesis are equal, greater than or equal to, less than or equal to. You cannot use less than here in null hypothesis. You can only use less than or equal to, or greater than or equal to. Now, the alternative hypothesis is always saying the opposite of what the null hypothesis is saying. For that, look at the symbols we use for alternative. Not equal to, greater than, less than. So these symbols here, you cannot use them in null. See? And the one for null cannot be used in alternative. Now, if you remember, I mentioned that if you say that you are 90%, 95% confident, your chance of being wrong is 5%, right? So that means that is a typical example of how the value of human error, and we recognize that in hypothesis testing. There are two types of errors we make. One is the type 1 error, and the other one is type 2 error. For type 1 error, it occurs when we reject a correct null hypothesis. If the null hypothesis is true and we reject it, then we committed type 1 error. Now, if the null hypothesis is not true and we did not reject it, we committed type 2 error. So type 2 error occurs if we do not reject null hypothesis when it is true, when it is false, I mean to say. Now, this might sound strange to you, so I'm going to use a chart to explain it more better. Let's say this is null hypothesis true, null hypothesis false. Reject null hypothesis. Do not reject. Now, if the null hypothesis is true, give me 1 minute. Yeah, let's go. If it is true and we rejected it, we have committed what is called type 1 error. See? Type 1 error. Because it is true, but we rejected it. Now, if it is false and we rejected it, we have made a correct decision. Okay? If it is true and we did not reject it, we made the correct decision. But it is false, even it is false, and we did not reject it, we have committed what is called a type 2 error. Type 2 error. Type 2 error. See? You can see right there. Okay? Now, okay, that's what it is. Now, let me use a real life example to explain this. Okay? Now, let me use this. Oops, excuse me. The scenario is, and we use the one that is common in America, jury. The legal system, very, very strong in the United States. Basically used for most decisions. I watch Judge Judy. Sometimes I watch Judge Mathis. I think I'm gonna move this to the next page so we can have an option. So even some family decisions are made in the court in America. It's normal here. So let me use that to illustrate this too. Now, in the legal system, in a trial, America use a jury trial. The hypothesis testing can be likened to that. In a jury trial, we have 4 possible outcomes, 4 possibilities. The defendant is guilty. The defendant is innocent. The defendant is convicted. The defendant is not, is not convicted or is acquitted. Okay? Now, 2 hypotheses are possible. The defendant is innocent or the defendant is guilty. Now, if the defendant is innocent, which is null hypothesis true, and we reject it, that means we convict him or her even though it is innocent. We have committed type 1 error. Okay? Now, if the defendant is not innocent, that means the null hypothesis is false, and we reject it, which means we convict. We have made a correct decision. Okay, decision. Okay. Now, if the hypothesis is true, that means the defendant is innocent, and we did not reject it. That means we acquit or release it, letting him go or let her go. We have made a correct decision. Okay. Now, if he's guilty, the null hypothesis is false, and we do not reject it. That means we release a guilty defendant. We have committed type 2 error. Type 2 error. That will give you a hint on what type 1 and type 2 errors are. Any question on this before I proceed?
Confusing.
Huh?
It's all right.
Okay, good. Now, note that the decision to of the jury is based on the evidence that they have. It might be right or wrong, but it's all based on the evidence. So if even though the defendant might be guilty, but there's not enough evidence to convict him or her, they will let go. You see it on the news. Sometimes people are innocent, but there are so many evidence pointing to them. Maybe witness testimony. They still send them to jail. And then after some years, now we are realizing the mistake they made like 20 years back, and now DNA tests is proving those people innocent, and you see them on the news all the time. It happens. So whatever they do, the only way you can be accurate if you interview the entire population, which is not always possible. Anyway, I think you get the point. Now let us move to how the type of hypothesis we have, how to state hypothesis. Yeah, let's see how to state hypothesis. So we look at some examples on. Excuse me. This I think I should bring it up instead on how to state hypothesis. Okay. I'll make this one to be 18. I made the rest to be 16. Okay. All right. How to state hypothesis. Now, it says state the null and alternative hypothesis for this conjecture. A researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. The average birth weight is 8.6 pounds. So you have to recognize the keywords that will help you to state the hypothesis correctly. Solution. Okay, you have HO is null hypothesis. H1 is the alternative. Okay. All right. And this is for this class we limit ourselves to hypothesis testing for the mean. It said there is such a thing that if the expectant mothers use vitamin pills, the birth weight will increase. See, will increase. And remember, you can only use will increase means greater than, right?
Right.
And you can only use that in the alternative hypothesis. Here you can see why I wrote it down. I wrote it down. I want to put it to see. You can only use this in the alternative hypothesis, right? So that means we have here we increase. That means mean. Okay. Let me bring this down. Mean. Okay, greater than 8.6 pounds. 8.6 pounds. That's what he's claiming. His claim. Okay. Now the non-alternative hypothesis, they're always saying the opposite of the other. So this one will say the opposite of this. So you can say mean. Okay. The opposite of increase is decrease, right? Am I right or wrong?
Yes.
So mean R is less than what is it? Less than 8.6 pounds. But the problem is that you can't use less than in the null hypothesis. Let me remind you again, for the null hypothesis, you can only use less than or equal to, greater than or equal to, okay? So that means we will be using less than or equal to in this one, less than or equal to, instead of less than. So that is how we state hypothesis. So less than or equal to. So I'm gonna this is the hypothesis we have stated them. See? Now, any question on this? Okay, good, excellent. Now, let's look at another example. It says an engineer claimed that the mean number of defects can be decreased in the manufacturing process for compact disc by using robots instead of human beings for certain tasks. See, can be decreased, the keyword there. That means less than, right?
Mm-hmm.
So by using robots. So the mean number of defective discs per 1,000 is 18. So you have your HO and H1. Now, I want to remind you something. Remember, we are doing hypothesis testing for the mean. So you can see the mean right here. That is the parameter right there. That's the parameter we are testing for. So it says can be decreased. Can be decreased. That means you can. It should be on this alternative. But that's where you can use less than. So that the mean, okay, is less than 18. That's your claim. Okay. Then this one says the opposite. So it's gonna be mean greater than. But you cannot use greater than here. You can only use.
For now,
Huh?
for now, literal is the opposite of the claim.
Both of them are, yeah, opposite of the claim. Yes. Now the claim can be in the null sometimes. I will show you where the claim is in the null. It can be in when you read the question, you see the keyword that will tell you where the claim will be. And null and alternative, they are always opposing each other. Okay. So that mean will be the opposite of this is greater than. But since we can't use greater than here, you can only use greater than or equal to. So that's what we're gonna use. Greater than or equal to 18. Okay. All right. Question. Very good. Very good. Now how about this one? It said a psychologist feel that playing soft music during a test will change the result of it. Will change. It didn't tell us whether it will increase or decrease, right? Did it? It said will change.
No.
So it didn't say whether it will increase or decrease. So that would be I think I may send you something. Okay. So we change. So we have it like HO and H1. HO and H1. Okay, we change. That means mean it can increase or decrease. So see, so we can only use this symbol for this is the symbol for will change, which means that not equal to. It can decrease or it can increase. 73. The opposite is that the mean is equal to 73. So this is say will change. Will change is right here. That's where the claim is. Will change. See? Now, I want to tell you something more. Whenever it is, the claim is greater than, we call it a right third test. So just one third test. We'll call it one third test. Let's call it one third test for now. One third test because it's increasing, going to one side, right? The same thing with this one as well. You say with the claim is a decrease. It is also one third because it's going to the left third, one side. But here, when it's not equal to and equal to, we call it the 2/3. That means it can be both sides. It can be on the left side, or on the right side. See? 2/3 test. Now, so this is hypothesis test for me. Now, so we are not going to do proportion test, but I'm going to show you how to state the hypothesis for proportion. Like it says, at least 45% of senior citizens wear hearing aids. Now, this does not mean, remember, this one's an average. We increase the score. So this one is this is mean score. See, mean score. So we use simple mean. This one also mean number. See, we use mean. For proportion, we use P for proportion. So it says at least 45% of senior citizens wear hearing aid. At least means greater than or equal to. So you have HO and H1. So you have at least means greater than or equal to. So P, why are we using P? Because this time we are looking at percent, not mean. Greater than 45%. And that is the claim. Claim, we'll say at least. Then the opposite is less than or equal to. Less than or equal. But we cannot use less than or equal to on this side. You can only use less than. So you can use P to be less than 45%. Okay. Now let me do one example where the claim is on the the claim is on the null. Right here is on the null here. It can also be on the alternative. But let's finish this one before we do the null one. Say more than 70% of college employees contribute to the United Way Fund. Okay, HO and H1. More than means greater than, which can only be used in the alternative. So P is greater than 70%, which is the claim. So that the alternative, null hypothesis will be P less than 70%. But since we cannot use less than on the null, we have it this way: P, okay, have less than or equal to. Should have it, yep, less than or equal to 70%. Okay. So I want to show you because in the homework you will be seeing if I give you a hypothesis testing question, the point would be like three different kind of points. One is stating the hypothesis. Two might be the getting the test statistic. Then three will be conclusion. So that you need to know how to state the hypothesis correctly. Here it says the average income of accountants is 51,498. So you have HO and H1. Okay. Is here means equal. So that means mean, okay, is equal to 51,407, and that's your claim. Okay. Then the opposite is mean is not equal to Okay, not equal to is right here. 51,000. Okay, 497. Yeah. Okay, now last but not the least, before we look at the other concepts, please can you mute yourself, please? You have this now. This one have HO and H1. So the average age of atomists is 25.4 years. So you say is again, see is. We mean that mean equals 25.4 years, which is a claim. Okay, alternative is mean is not equal to that. Mean is not equal to that. 25.4 years. So this is how to state hypothesis. State the use the correct parameter and get the hypothesis. Now, any question before we look at the terms we use in hypothesis testing?
When do you use the mean symbol versus the p?
When you say the average, use the mean. But when you say what is a percent, use the p.
Okay, thank you.
You're welcome. Now, any other question? Okay, good. Since there's no question, we can look at the terms we use in hypothesis testing. Okay. Okay, we have this. This should be. Now look at the. Let's start from here. Terms. Well, put these things in. And then 16. First is significance level. The significance level is basically the probability of committing type 1 error. Explain what type 1 error is. Rejecting the null hypothesis when it is true. Now, it is also called the significance level, or we did that when we did that when we were doing a confidence interval. So the probability of committing type 1 error is the alpha. Remember the alpha. So if you say that you are 95% confident, or that it is 95% significance level, that means the chance, the error of the chance of being wrong is 100 minus 95, which is 5%. So alpha is 5%. So the significant level is the probability of rejecting the null hypothesis when it is true. We use it to determine the critical region. Now, the critical region is a region basically it is the cutoff value. So any answer, if the answer falls in the critical region, you reject. So we can call the critical region the rejection region, basically. The critical value is the next term, which is the point on the test distribution that is compared to the test statistics. But basically, I'll call it the cutoff point. So number where you start to reject, it shows you the boundary. From that boundary up, you can start to reject. I'm going to show you this. You said that a picture speaks more than 1,000 words, so I'm going to use picture to show this. I remember I mentioned that there are two types of tests: the the left two-tail and one tail. So look, assume that this is a two-tail test. You see where I shaded here. If your answer falls here, you reject HO. Or if your answer falls on this side, you reject. But here, it's not shaded, so this is the acceptance region. If your answer falls on this region, you don't reject. So this region where when your answer that is shaded is the critical region or the rejection region. Now you see that line, this line here that cut the critical region off from the non-critical region is the one we called the critical value. So the value at that point. So for the left tail test, if your answer falls in the critical region, you reject. See? But if you fall in the acceptance region, you don't reject. The same thing with the right error test. If your answer falls in the critical region, reject. If it doesn't fall in that, you don't reject. You see that when we start testing hypothesis, I will show you more on that. So we'll come back on Tuesday. We'll begin Z test for the mean. Okay. So if you don't have any question, let me take your attendance so that you can leave. Okay. I'm sorry, Miss Spears. I see you.
Yep.
Miss Spears, are you okay? That is a celebrity. They call it Britney Spears. You know who she is?
Yes, I know who Britney Spears
Is it your cousin or?
Nothing, not related at all.
Oh, okay, my bad. So I got you. Kanisha, I have to Kanisha M. Okay, got Kanisha. Kanisha. So when I get your name, if you can leave. Say who's Kelly? Kelly, you there? Kelly. Okay, got you now. You can go now. I don't know who is this sweetheart. Is it Laguz?
Yeah. Yeah.
Okay, got you now. So you can go now. Have a good night. Pesha Smith.
Yes.
So have a nice week. Have a nice holiday.
Thank you.
Who is Mona with? Okay, is it Brianna? Brianna Ash, right?
Yes, I'm sorry. That's Brianna.
Okay. Enjoy your holiday. Who else is here? And oh, Nicole. Okay, Nicole White.
Hi, Professor. How are you? Happy Father's Day to you.
The same to you. Enjoy your weekend.
Professor, I said Happy Father's Day. I'm not a man.
Oh, say it again.
I said Happy Father's Day. You said same to you. I said I'm not a man.
Oh, I thought you said Happy Holiday, actually.
Happy Father's Day, Professor.
Thank you. Appreciate.
I'll see you on Monday.
Monday? It was you that told me that Monday was public holiday. Right or wrong? Am I right or wrong?
You're right.
You're right.
Okay. So I see you on Tuesday then, right?
I'm okay with that too. I'll see you on Tuesday.
All right.
All right.
Professor, I only got one question.
Go ahead. Olubimi?
What? Yes.
Hold on, Miss Pierce. Olubimi, you there?
Yes, I'm here.
I got you.
Good
I got you.
Professor.
Yeah, how are you?
Okay, thank you.
You're welcome.
I'm good. Yeah.
Okay, good night. Miss Pierce, say you have a question, right?
Yes. How do you make
Sarah, Professor?
Who?
Sarah Niger.
I only see iPhone. Are you the one with iPhone?
Yes.
Oh, okay. Okay, I got it now.
Okay.
Yeah, so have a good night.
You too. Bye-bye.
Yeah, Miss Michelle, go ahead.
Yes. How do you draw your lines to do the bell shape and all that? I don't know how to do that.
Oh, I can show you better in the class, but let me see if you still have more time.
Is it in Word?
It's on Word. Look, if you be on Word, then you're gonna click. I don't know if you can see this. Can you see where you see say insert?
Yes.
If you click on that, it will give you all the shapes. See, there's this shape. See,
Right.
Okay. From there you can pick this.
Yeah, that's what I was looking for. I couldn't find it. Okay.
Yeah.
Because I'm telling you, I'm having a hard time with this bell shape stuff. All right. I'll have it because you need to change it. You have it due tomorrow at 11:59 a.m.
A.m. Let me change to PM then.
11:59 a.m.
Let me change it to PM then. Can I say it again?
Yes, change it.
You gotta be PM. You gotta be PM. Which assignment is that?
Classwork 6.
Classwork 6.
Yeah.
I think that thing is is always. I think it's by default. So I'll watch out for this now, because I always let me change this to PM.
Yeah, PM.
PM. Okay. Yep, done. And okay, saved. So it's PM now. You can double check it. Today's date is 6/15/22. Okay.
Oh, yeah, and don't forget to send the other thing too.
To upload it, right?
Yeah, to upload this today thing for me, please.
Let me save it first. All right. All right. You have a good night now.
All right. Thank you, sir. You have a good evening.
You too.
Happy Father's Day.